So, good morning to all. In last video, we have seen that linked list representation by the help of array. Okay, and in this lecture, we will see linked list representation by the help of structure. So, let me repeat the things. A structure is a collection of different type of data. Okay, it means in a structure, what we are going to do, we can collect different type of data. Okay, so first of all, we have to see what is the idea behind this. It means we are going to implement linked list with the help of structure. Okay. So in this series, first of all, let me explain you what is structure and what is linked list. Okay. So let's say I have a start pointer like this. So sorry for the disturbance. So let me explain to you. We have a start pointer. So that is start, and along with start pointer, I have a linked list like this. So I have already explained you that in linked list we have collection of nodes. Okay, in nodes we have two parts. That's node number 1, node number 2, node number 3, and node number 4. Let's see, the address of first node is 10. So in its start we will put the address of first node. Okay, then that is the data part, let's say 20, and that is the address part. It means in the address part I am going to store the address of the next node. Let's say the next node address is 100. So I am going to store 100. Are you following this? Okay. Let's say it is 35 and that is 6. Let's say the address of the next node. Okay. And then data, and then let's say that is 72, address of the next node. And let's say data is 192, and in last we have null. Are you following this one? So what we have seen there, we have seen that a linked list is a collection of nodes like this, and every node contains two parts. The first one is data, and the second one is address of a next node. So what is the meaning of this one is? The meaning of this one is in linked list. In linked list, we have two things. The first one is data, and second one the address of a next node. Okay. So first of all, we have to see, can we implement linked list with the help of structure? So what is structure? We have seen that a structure is a collection of different type of data. It means here we have two things, data and address, and structure says that you can collect different type. Are you following this one? Different type. So what is the meaning of this one is, if I will take two element in a structure, so I can implement linked list. Okay. So let me define the structure of like linked list. Can you write something like struct, struct, that the name of the structure, that is called list. And in this one, what we have to do, I have two things. First one is data and second one is address. So let's say the type of data is integer, so I have put data. And the second one we have to save the address. So what is the meaning of this one is, whenever we talk about the address, what is the meaning of this one is, we have to store the pointer. Okay, we have to use the pointer. So what we have to do, I have to store the address of a node. Are you following this one? Let me explain again. I have to store the address of a node. It means the address of this node has been stored in this one. Okay, if the type of this node was integer, so I will take integer pointer. If a type of this node is what, float, so I will take float pointer. But what is the type of this one? The type of this one is struct list. So I will take a pointer of type struct list, and the name of the pointer is next. Are you following this one? So what is the meaning of this one is, the meaning of this one is a structure named as list having two parts. First one is data. It means I will store data, and the second one is the pointer. Which kind of pointer? The pointer is struct list. It means it has an ability that it can store the address of type struct list. idea that with the help of linked list, sorry, the structure, I can implement linked list. So let me explain the program. So let me explain the program. First of all, I have a structure list. And in structure list, what we have done, I have two parts. The first one is data, and the second one is pointer of type struct list. So what is the meaning of this one is? The meaning of this one is this variable have an ability that it can store the address. Which kind of address? Struct list. Okay. Then let me define main. So that is main. Okay. So I will write like this. Okay. That is main. So first of all, what is the requirement in linked list? You have seen that first of all, you have to take a start variable. So start variable contains the address of first node. Are you following this one? Start variable contains the address of first node. So in start variable, we don't have a data part. Are you following this one? In start variable, we don't have a data part. The only thing is the address. So let me take start. So the type of this one is struct list pointer start. So why we are taking start? The purpose of taking start is I will store the address of first node. Are you following this one? So let me take a first node struct list L1. So the moment you will write L1, what is happening inside the memory? Inside the memory, there will be the block named as L1. Okay, so contains two parts. The in first no, block you can store the data. In the second one you can store the address. Okay, so let me store the data. L1 equals to 20. Okay, L1 equals to 20. So what I have done, I have put 20 in this block. Okay, sorry, L1 dot data. Sorry for this. L1 dot data equals to 20. That is this one. Okay, so in second block, what I have to do? In second block, I have to put null. So L1 dot next equals null. Okay, so I'm writing null, so you can check how we can write null in C language. But what the purpose of this one is, I have taken a structure, and in structure I have taken two fields. In first one I have saved data. In second one I have saved the address of the next block. Okay, so till now we don't have a next block, so we have put null. But the address of this block should be saved in a variable start. So what is the meaning of this one is, we have to copy the address of L1 into start. So what is the meaning of this one is, I am going to put the address of this block into start. So what will happen? By putting the address of this block into start, I am going to link these two blocks. It means start will say where the first block has been allocated inside the memory. Are you following this one? That is quite easy. Then let me allocate the second block. So I can apply loop, but for the sake of simplicity, I can write like this: struct list L2. So what is going to happen? The moment I am writing L2, so what will happen? A separate block will come inside the memory named as L2. I can put data and I can store the address. So let me put data L2 dot data equals 40. So what is the meaning of this one is, I have put 40 in this one. Are you following this one? I have put 40 in this one. Then what I have to do? I have to put null here. This end of list. So I can write L2 dot next equals null. Okay, L2 dot equals null. So what is the meaning of this one is, I have put null pointer. But there is a problem there. Till now this block and this block are independent. So what I have to do in order to make a linked list, I have put the address of this block here so that these two blocks will be linked. Are you following this one? So what I have to do, I have to access the L1 dot next. So I will write L1 dot next. So I have to copy the address of this block into this block. Okay. So what is the name of this one? The name of this one is L1. So L1 dot next. We have to copy the address of L2. So let me copy the address of L2. So what is happening? So these two blocks will be linked like this, like this. Okay. So what is the purpose of this one? First of all, I am going to create a node. So in order to create a node, what I will do, I will take a variable of type struct list. Okay. The moment I will get a variable, so what I will do, I will link them. Okay. So let me show one more time. I am writing here. So let me take a variable struct list L3. So let me copy the data. L3 dot data equals 13 and L3 dot next. So what is the meaning of next? I will copy null because after that I don't have any block. And in the L2 part, L2 dot next, I have to copy the address of L3. So what will happen? A node will be created. We can put a value of like 30. In the address part, I have put null. And what is happening? I am copying the address of this one into this one. So these two blocks will be linked. Okay. So that is the example. In this example, we have seen that with the help of a structure, I can make linked list. Okay. Are you following this one? It is quite easy. I can make linked list. So that is quite easy. So in the next lecture, we will see that various operations on linked list. Okay. So we have seen that in data structure, we have 5 basic operations. Okay. So let me give you the name of 5 basic operations. So we have seen that the 5 basic operations of DS are traversing, number 2 insertion, number 3 deletion, number 4 searching, and number 5 sorting. Okay. So in some books we have given one more, that is merging. Okay. So in a case of array we have seen traversing. So in the case of array, traversing was quite easy. Okay. We can apply a loop from I equals to 1 to the length of array, and we can print the value of ai. Are you following this one? In the case of array, traversing was quite easy. Now we talk about insertion. In insertion, what we have seen that in order to insert an element inside the array, we have to perform shifting from left to right. Deletion. So we can delete element by index or we can delete element by searching. It means if I have an array like this, when someone says that please delete element number 3, so what I can do, I can delete 31. If it starts from 1, I can delete 31. If someone says that please search 20, if present in array, then please delete 20. So what I have to do, first of all I have to perform searching. In order to search 20, if it is available, then we have to delete the element. It means element will shift toward the left. Okay. So in the case of array, insertion and deletion, shifting take place. Okay. And searching, so we have seen that 2 type of searching inside the array. The first one is linear search and the second one is binary search. Okay. And we have seen that the condition for binary search is the element should be increasing order or decreasing order. Okay. Sorted. Then sorting, so till now we have seen 2 sorting. The first one is insertion sort, Second one is bubble shot, and third one is selection shot. So we have seen three type of shorting. Okay, and then merging. So we have left with merging. Okay, in a case of array. Okay, so what will happen when in a case of traversing? What will happen with linked list? So let me give you the idea about this one. So let's say I have a linked list like this. I have a start pointer, and that is the first node. The data is 30. So it contains the address of second node like this. Let's say the address of is 70. So I will put 70 here. Let me take in data. Let me take third node like this. Let's say the address is 7. So I will put 7 here. The data is like say 129, and let's say that is null. So in a case of array, what was the advantage? In a case of array, why I am going to traverse the data, I can apply a loop from 1 to n, because element can be accessed with the help of indexing. But in a case of linked list, whether I will implement linked list with the help of array or with the help of a structure. So I have two ways I can implement linked list, but in both the ways, there is a problem that how we can start. Okay, so in order to traversing the linked list, I have to start with a start variable. So I will take a pointer named as ptr, and I will copy the value of start, because the start variable will contains the address of the first block. Are you following this one? So what is the identity? In a case of array, the identity was 1, because the indexing of array starts from 1. But in the case of linked list, we can't say that the first element will be stored at the first location or the first address. So which variable holds the address of the first block, that is start. So what we have to do, I have to copy the content of start into ptr. So ptr contains the address of a first block. No, sorry, like this. Okay, address of a first block. Then what I can do, I can access the info part or data part. Okay, both are the same thing. It means info part of the block. Then I have to update. How we can update? We can update ptr as info sorry, like next ptr. You can write like this, next ptr, like this. No, like this. So what is the meaning of this one? Is the meaning of this one is, please copy the next part. What is the next part? The next part is 70. So the meaning of this one is copy 70 in ptr. How we can access this one? Because let me explain the by example. So let me rub this one. So in this video, we will see only the single algorithm, that is called traversing. So let me explain to you. Let's say I have implement linked list with the help of array. So what is the condition? The condition is I have like this one, that is 10, 20, 5, 9, 3, 6, 2. That is the data part. And the next one is like next block. We can write next block, or we can say link, whatever you like. Link. Okay, that is the link part. So in the last lecture, we have seen that with the help of array, we have to implement linked list. So we have to take parallel arrays. Okay, so let me take start. Let's say the value of start is 3. It means first block start from here. After first block, the next block is 1. So I can write like this, and next is 4, then 3. Oh, we have already taken 3. So let me rub this one. That means 6. So 1, 2, 3, 4, 5, 6. So the next one is 2, then 5, then 7, then null. So how we can traverse the linked list? First of all, I have to start with start. So let me take a pointer. PTR equals start. So what is the meaning of this one is? The meaning of this one is I have saved the value of start in PTR because I want to store the address of first node. So I have taken temporary variable PTR and saved the variable. Then I have applied the loop till PTR not equal to null. So what is the meaning of this one is the moment I will find null, it indicates end of block. Okay. Then we can print whatever you want to write. Info part of PTR. Let me write first PTR, that is 1, then 2, then 2 ka A, then 2 ka B. PTR equals to next of PTR. Sorry, link of PTR. So let me explain to you what is the value of PTR. The value of PTR is 3. So it becomes info of 3. So what is info? Info is an array. So we have taken data. So you can change the name. So info data. Both are the same thing. Okay. So we have taken the info part of 3. So what is info part of 3? That is 1, 2 and 3. That is 5. So it will print 5. Then link part of PTR. So link is an array. This one. And the value of PTR is 3. So it means the next block can be found at the first position. So the last value of PTR was 1. Sorry, 3. Now it becomes 1. Are you following this one? The value of PTR was 3, but now you have updated the value of PTR by link of PTR. It means you are going to save the address of this block. Are you following this one? So the value of PTR becomes 1. So PTR not equal to null? No. 1 not equal to null. Condition becomes true. Info of PTR. So the value of PTR is 1. It means you are going to access the info part. So what is the info part? Info part is 10. So it will print 10. Then link of PTR. So link of PTR is 4. Copy in the PTR. So the value of PTR becomes 4. So next block can we find at the fourth location, that is 9. Then PTR becomes 6. And the sixth block, that is 2. Then the 20. Next block can be found at the fifth position. So we will give 3. Then the PTR becomes 7. Like this. Then 2. Then the PTR becomes null. The moment the PTR becomes null, we will come out of the loop. So in the same fashion, we have printed all the values of linked list. That is called traversing of linked list. Okay. So if you are getting something, you can like predict that in a case of linked list, what we have to do, either we have to take structure or we have to take parallel arrays. Okay. In the case of parallel arrays, we have to take a variable PTR. In that variable, we will copy the value of start, it means start pointer, and then what we have to do, every time we are going to print the value, in order to get the address for next block, I have to access the link part, or we can say next part, whatever is the name, doesn't matter. Okay, so that is traversing of linked list. Okay, so you can write down the videos. Thank you.